I guess we're going to start talking about equations. A lot of math is about equations. And the first thing we're talking about is linear equations. Those are equations that just have a single variable. Usually we use x. And there are sort of three categories of equations we want to talk about. The first is called conditional equations. This is the most common kind of equation. The second is called identity. So the category is identities. And the third is called contradictions. So let's talk about conditional equations. A conditional equation is an equation that is true for the right value of the variable. So a classic conditional equation would be something like 3x plus 2 equals 0. And we'd say, gee, when is it true that 3x plus 2 equals 0? Well, I'm going to try and figure out a value for the variable x that'll make this true. And so what I'll do typically is I'll try to isolate the variable. If I could end up with something like x equals blah, well then I know what the variable is equal to. So how do I get x by itself? Well, I perform operations to this equation that create equivalent equations. So this equation here is equivalent to an equation with 2 less on each side. In other words, I'm going to subtract 2 from both sides. I'm going to get 3x plus 0, I won't bother to write that, equals negative 2. So this equation is equivalent to that equation. Now, I'd really like x by itself. I know that the way that you can undo multiplying by 3 is dividing by 3. So now I'll divide both sides by 3. That makes this side x, and this side negative 2/3. So this equation is equivalent to that equation, is equivalent to this equation. And the set of solutions here is just the value, some people write as a solution set, negative 2/3. That is the only value, the one and only value that would make this true. Now an identity is going to always be true. So for instance, here might be a classic identity, 2x plus 1 equals 2x plus 2. Okay? So this is always true. If you're having trouble seeing that, you might practice distributivity. So notice 2 times the quantity x plus 1 is equal to 2x plus 2 times 1, 2 equals 2x plus 2. And then if you were going to perform these sort of operations, an equation that's equivalent to this would be to subtract 2 from both sides. So then I get 2x equals 2x. Now, I might gather my 2's on one side by subtracting 2x. That gets me, 0 equals 0. So I guess you could ask the question, what value of x would make 0 equal to 0? Well, any value of x. So all real values would make this true. So essentially you have something that's true some of the time, that's why it's called conditionally. This is true all of the time. Well, you can imagine what contradiction is. That's true none of the time. So let's imagine that we had 2 times x plus 1 equals 2x minus 2. Well, that looks like a great equation. Only problem is there's no value of x that is ever going to make that true. How do you see that? Well, let's distribute, as in the last step. The nice thing about having this as a video is if you need to slow down, just feel free to pause and go back. Now I'm going to gather my constants over here by subtracting 2 from both sides. Now I'm going to move my x's over to the left-hand side, so I'll subtract 2x. The problem is it doesn't just cancel over there, it cancels there, and I get 0 equals negative 4. So the question is, what value of x will make 0 equal to negative 4? And the answer is no solution. There is no value of x that will make this equation true. So, conditional equation, identity, contradiction.